Guanda International Machinery introduces Smart System Integration, SSI, a flexible and modular solution designed to meet diverse process requirements and site conditions, enabling the creation of highly efficient smart production lines. Through smart integration, SSI enhances automation and operational collaboration, achieving optimized human-machine coordination. This video presents simulated scenarios to demonstrate the core architecture and operation of SSI. The integrated equipment includes SLM, Steel Laser Marking Machine, STD, Steel Tri-Spindle Drilling Machine, SBS, Dual Angle Steel Band Saw, -45 degrees to 60 degrees cutting range, with Material Distribution Module, HQB, End Beveling Machine, AGV, Automated Guided Vehicle Module, SFM, Steel Fabrication Management Software. These machines are interconnected through an automated material handling system, centrally managed by Guanda's proprietary SFM software. Integrated with SSI, Smart System Integration, they enable cross-equipment collaboration and real-time monitoring. The entire production process begins in the design office. Product data is created using 3D BIM design software, converted into NC format, and embedded into the SFM system. This system is connected to the central server database, which acts as the monitoring hub for unified management and distribution. The embedded project data is simultaneously transmitted to all machines on the production line, ensuring that every piece of equipment can access consistent production information in real time, enabling an efficient and collaborative smart manufacturing workflow. Operators decide machining tasks from project work orders and load the steel data into the machines. Once the AGV transport module is activated, project data from the central database is instantly synchronized across all machine and stations. The entire workflow is coordinated by the buffer module within the SFM system, which plans machine operations and transport routes to ensure steel enters the production line in sequence and completes each designated process. The AGV fleet detects the steel material using photoelectric sensors and positions it in the processing area. Once the material is ready, the system automatically transfers it onto the roller conveyor to begin the machining process. While the first material piece is being processed, the next has already been advanced by the AGV fleet into its standby position, enabling continuous operation and overlapping workflows. Guided by BIM data, the SLM, Steel Laser Marking Machine, marks sub-component positions, numbers, graphics, and QR codes on all four sides of the steel material. Encoders and sensors on the machine and conveyors record the material's position in real time, ensuring precise alignment. As the steel passes the discharge sensor, the next piece is automatically fed into the in-feed conveyor and transferred to the machining station, achieving seamless flow and high-efficiency operation. The in-feed conveyor is equipped with dimension detection, measuring the material's height and width to ensure compliance with the processing parameters specified by the SFM system, thereby enhancing process stability and consistency of quality. Between two machines, the cross-conveyor serves as a buffer, effectively balancing the production rhythm of different stations. When the first material piece is moved to the in-feed conveyor of the STD, Steel Tri-Spindle Drilling Machine, the remaining material on the cross-conveyor automatically repositions, aligning closely at the loading side to free up space for the next batch, thereby accelerating the overall production flow. The feeding arm of the STD automatically locates and clamps the material, initiating the machining process. The STD can simultaneously perform drilling, tapping, and milling operations on three sides of the material without waiting, greatly enhancing processing efficiency. The entire production line is centrally controlled by the intelligent SFM system, precisely tracking the position and dimensions of each steel piece to maximize machine throughput and minimize downtime. All operations are monitored in real time from the operator console and the server hub, ensuring a seamless workflow. When the first steel piece passes the STD outlet sensor, the next piece is already pre-positioned on the in-feed conveyor, reducing machine idle time and cross-station transfer delays. Before the steel piece reaches the in-feed conveyor, the system automatically slows down to prevent collision and reduce noise. After the steel exits the STD outlet, the SFM system immediately determines the optimal route to the next station and commands the corresponding cross-conveyor to move into position to receive the steel. At the same time, the roller conveyor transfers the steel onto the cross-conveyor, further shortening transfer time and ensuring an uninterrupted production flow. The feeding arm of the SBS, Dual Angle Steel Band Saw, automatically locates and clamps the steel material, then transfers it into the machine for angle cutting within a range of 60 degrees to -45 degrees, meeting the processing requirements of diverse structural components. During the cutting process, the discharge side feeding arm simultaneously transfers the steel material to 3 designated zones: scrap zone, short length zone, and long length zone, achieving synchronized cutting and sorting without any waiting. For steel materials classified as long length, the system automatically transfers them to the next workstation. At this stage, the SFM system intervenes in real time, assessing the subsequent processing requirements of the steel and directing it along the optimal path. If the steel material requires end beveling, the system assigns either the left or right cross conveyor to deliver the material onto the central roller conveyor. If end beveling is not required, the steel material continues along the main line and proceeds to the next stage of processing. The entire process is intelligently managed by the SFM system, ensuring accurate steel classification, clear routing, and smooth workflow, thereby further enhancing production line efficiency and processing precision. When the roller conveyor at the HQB, end beveling machine, inlet detects no steel material, the cross conveyor on either the left or right side automatically activates to load the steel onto the roller conveyor and move it to the HQB inlet for end beveling. After the first end beveling is completed, the steel passes through the HQB body and is system controlled to reverse back into the processing area for beveling on the opposite end, achieving a seamless, uninterrupted process that completes double end beveling in one cycle with high efficiency. The AGV transfer module consists of 3 independent AGV fleets. Through coordinated division of labor, they sequentially transport steel from the 4 roller conveyors on the right side to the 2 conveyors on the left, achieving efficient material transfer. The transport sequence is optimized by the SFM system's self-developed AGV multi-agent path planning algorithm, which dynamically schedules operations in real time based on on-site conditions to ensure smooth workflow, shortest routing, and minimal waiting. This algorithm effectively reduces transfer time, prevents bottlenecks and interference, and ensures a stable production rhythm, thereby maximizing overall output and minimizing delays. Steel structure processing values efficiency. Laser tube cutting machines offer flexible multitasking, quick design switching, precise stability, and lower costs. They boost competitiveness and drive industry upgrades, making tube processing faster, smarter, and a powerful force for engineering progress. Plate cutting is time-consuming, and traditional methods are slow and imprecise. Laser plate cutting machines deliver fast, accurate results, completing diverse shapes in one step. They shorten cycles, reduce costs, and boost output, driving the steel structure industry toward high-efficiency production. SSI, Smart System Integration, Intelligent Manufacturing Integration is a core technology independently developed by Guanda International Machinery. Through the SFM system, it fully connects cross-conveyors, AGV fleets, and various processing machines to construct a highly coordinated and flexibly configured smart production line.